This is the Section 3.1 MathCast. It contains 5 lessons. Because they are intuitive, two-way tables are used as the base model for solving simple probability problems involving two categorical variables. Students perform probability calculations intuitively as an extension of two-way tables. Students extend what they learned about statistical association in chapters 1 and 2 by creating and interpreting conditional relative frequency tables. Students learn probability notation and derive common probability formulas as an extension of their work on two-way tables. Students learn how to get tree diagrams and relative frequency two-way tables to work together in situations where conditional probabilities are given. Students learn to analyze systems designed to detect rare events, but as a result have problems with false positives, or more commonly called false alarms. Students will look at several such systems, such as HIV and drug tests, to decide whether the social cost of false positives is greater than the benefits of true positive results. In Lesson 3.1.1, students compare two-way tables to Venn diagrams, which can have more than two variables but are limited to only yes-no responses. Then joint and conditional probabilities are found intuitively from two-way tables. Probability is formally defined in a Math Notes box. If readily available, your two-way tables and Venn diagram posters from Lesson 1.1.1 make excellent additional examples. Students are introduced to the difference in meaning between probability or chance and confidence or certainty. This distinction is important for understanding the language they will use to describe their conclusions in chapters involving inference. Let your students find probabilities intuitively from probability tables. Don't let them use probability formulas yet. The formulas will be derived later in Lesson 3.1.3. In Lesson 3.1.2, students revisit a concept they saw in Problem 119. Students are able to reason through a simplified version of Bayes' theorem, then make comparisons of conditional probabilities to determine association or independence. If you're not particularly experienced with finding association on two-way conditional relative frequency tables, it's highly recommended that you work through these problems yourself before guiding your students through them. Problems 3.14, 3.15, and 3.16 provide additional opportunities for students to work with tables to compute conditional probabilities. Problem 3.16 comes with a resource page. Again, refrain from a formulaic approach. Trust that if your students can build a two-way table from a problem prompt, they can intuitively reason any asked-for probability. Students are looking for matching conditional probabilities to show independence, or conflicting conditional probabilities to show association, but are able to reason that if data represents a sample, they cannot reasonably expect them to match perfectly for independence. Students are confronted with the decision of how much variation is enough to claim a relationship. This is an excellent preview of the inference with categorical variable concepts found in chapters 7, 8, and 9. In Lesson 3.1.3, students are given shorthand symbols for common probability situations of and, or, and not. Just as students reason calculations from joint and relative probabilities, they are able to reason formulas from probability notation. Lesson 3.1.3 includes a Math Notes box clarifying the terms independent and association with examples. The addition rule and a simplified version of Bayes' theorem are derived from the two-way table in Problem 3-23. You want to push your class to complete this problem during the set and be comfortable leading the derivations if necessary. Lesson 314 reinforces the simplified Bayes theorem derivation in the first problem. As important as formulas can be, realize it's more important that your students are comfortable reasoning calculations from a two-way table full of joint frequencies than having to focus on the formulas, which are often forgotten or misapplied. There is no place to put conditional probabilities directly into a two-way table, but conditional probabilities can intuitively be placed on tree diagrams. Lesson 314 shows how the two models are related and how to get them working together. You may need to practice your familiarity moving between these two models. There is an additional example given in the teacher notes. When a probability prompt includes conditional probabilities, this curriculum suggests students use a tree diagram as an intermediate step in creating the relative frequency two-way table to find joint probabilities. Lesson 315 uses the Midnight Mystery prompt. Your students may be familiar with this prompt if they have a background in the CP&M Common Core curriculum series. But don't be tempted to skip this lesson. It serves as a lead-in for the base rate fallacy concept and more problems where the probability of A given B is much different than the probability of B given A. If you're not familiar with the Midnight Mystery problem prompt and solution, you would be wise to preview it to increase your confidence with the calculations and conclusions. Problems 338 and 339 are similar in concept. Because of the relatively large and small probabilities used, these types of problems require working with at least 5 sig figs. This tends to make students feel uncomfortable, so they will need reminding that they do have calculators that can handle the task with ease. Lesson 315 is a preview of the concept of power of a test from Chapter 8. In these alarm examples, a false alarm would be considered a Type 1 error. A Type 2 error would be the more serious failure to detect a real threat. The only way to minimize false alarms, yet detect real threats reliably, is to have a powerful alarm, in this case a powerful test. While AP exam free response questions that focus solely on probability rules are uncommon, they are often tested in the multiple choice format. The problem generator is a deep resource for these kinds of multiple choice test questions.